Hi everyone, Ashish this side back again. This time we are going to discuss about different architectures that are GenAI architectures that are also AI architectures that are used to generate images. One of the most popular architecture out there is GAN, which is called a Generative Adversarial Network. That is the agenda of today's lecture as well. So basically all the image generators that we are talking about, they work on basic four principles. Apart from that, there are a lot of others as well, but they are the four principles. They works on GANs, they are the old models. They work on unit, they work on diffusion models, and autoregressor is the recent tech or technology that is evolving nowadays. And all these recent image generator that are generating very realistic images, where the distinction between a real image and a fake image is very less nowadays. Okay, now you know about nano banana. So it started from GAN architecture, which is called a generative adversarial networks, and this is what we are going to start as well. Imagine we have a person Alex. He's a thief, not a thief as you think as a thief. He's Alex, and along with that, we also have one more person, James. Okay, based on the outfit, you can see like what each of them is doing. So Alex looks more like a thief, and James look more like a critique or investigator. This is what they are as well. Okay, but they don't like working side. They are working along with each other. James is basically the one who critiques the painting, and Alex is the one who makes the painting. They are not like traditional thieves. They'll go to the place and stole the paintings. They make very realistic fakes. This is what they do. Okay, Alex is a great artist, but on the other side, James is a great critique. He knows the nuances between the painting. This is what a great painting. This is what is not there in an original painting. So both of them will work together, and because one of them is an artist, he'll make better and better painting just because we have a critique with him. Okay, so this is what they are. Now Alex works as a generator who is generating new content, new images or new paintings, and discriminator is James, who is more into finding nuisances, finding issues with the paintings. So the more and more feedbacks discriminator is giving, the better paintings will become. Okay, but both of them should work together, then only the things will go, and they can have great mention of great paintings and great fakes. But it will not act as if from day one they are making great paintings. Okay, from day one they are making very unrealistic fakes that anyone can see. But over the time their collection look like this as well, but over time they have a great mention with all the great paintings out there because they know how to make great paintings. Both of them are working together, but here's a catch. If now both of them are working, they have, now Alex knows how to make great paintings because of the feedback of James. Now once Alex knows how to make great paintings, he knows the nuances. Do we need James, or do we need discriminator? Not at all. James or Alex basically, or the generator, will work single-handedly to generate paintings as well, right? But Alex cannot learn from scratch how to make paintings without James, without discriminator. Okay, this is a very realistic example, and this is how GAN works. Now let's jump back to GAN architecture, actual architecture. So we have a training set. Think of the training set as the paintings that has to be made. Okay, we need to have some realistic paintings first of all. Like from these paintings, I need to make faces. This time I'm using a training set to generate real life images of faces, human faces. This is the agenda. Okay, rather than making paintings. So I need to have a realistic data set, and I need to have a generator, like the one who is making the paintings. Okay, so in the beginning, generator don't know how to make paintings, and generator need to have, think of it as a canvas. Okay, or some random input the generator need to have, and that input will be mapped to an image. But right now the generator is more of don't know how to paint, so it will generate images, but after the training process, in the beginning it will also generate random noise. Okay, but we need to take both of them side by side, and one side we have images, another side we have generator to whom I want to teach how to generate images. To do that, I need a discriminator. So here we have another module. Right now, just treat them as module, but they are individual neural networks. Generator is a neural network. Discriminator is another neural network that will generate images, and discriminator will discriminate. It's a classification based problem. It's real or fake. Now, if both of them are given the input, like this is what a real image, this is what an image generated by a generator, given to a discriminator, which is a classifier, it will tell you which image is fake, which image is real. That's pretty simple, right? Like even very basic discriminator or classification based algorithm can say this is a real image, this is a fake. But over time, I'll train both generator and discriminator. If I'm training them side by side, what will happen? The generator will understand how to fake the discriminator. To fake discriminator, the generator need to make more realistic images. This is how the whole flow goes. So here we have two neural networks that has to be trained side by side. A generator who don't know in the beginning how to generate images, but eventually learn. Because discriminator is discriminating, like this is a real image, this is a fake. So a discriminator is the critique, generator is the artist. Okay. Now, this is the whole architecture. Now, in this architecture, in the beginning, when the noise is given to the model, it will generate random noise, but over time, as you can see, images will become clear and better and more beautiful. Okay. But just generator is not enough. We need to have discriminator to train the generator. Once the generator is trained, then discriminator is not needed. Okay, now I can give any image of your choice. I can give the images of a cat. It will learn how to generate images of cat. I can give images of a dog. It will generate the images of a dog or any other choice of yours. But all these things are generated from this random noise. Okay, this random noise is pretty random for every image. Okay, so you can give any random noise of your choice, it will generate a random image. So here the issue is, if you are giving a random noise, it will generate a random image. If you are training an algorithm to generate the image of a cat, and if you are giving a random noise, it cannot generate the image of a dog, because the model is trained to generate images of cat. So in this case, to make a realistic scenario where it can generate anything, we need to give all the data, and every data will have a random noise, means we need to give random noise to generate some image. And this is the whole architecture. The image is generated from random noise. Every image has a map of random noise. Okay. Now, if I'm giving, there will be a random noise of a Persian cat and all the other indie cat, as we can see here. But if I'm taking the random noise, okay, because random noise is making the image, and these random noises, if I'm just talking about these random noises that are generating the image, because now I don't want the whole neural network architecture, just generator will work for me because I've trained the network. Now, if I take this network, and if I'm taking all the noises that can generate the image of an indie cat, and I will average out the noise, treat the noise as a number, an array of number. Okay, 10 by 10, 20 by 20, 100 by 100 size array. Okay, not 100 by 100 is too much, but 10 by 10, 20 by 20 size array of random numbers that we are eventually making images. Every random array will have different features into it, and all the images that can be generated in indie eventually coming from a noise. And if I'm averaging all the noise together of indie cat and Persian cat, so I'll have a noise that will always generate an indie cat, always generate a Persian cat, and I can map these noises. Once I have these noises, accordingly I can have a data set of all the different kind of images. I will train one single generator. I'll find the noise that is generating which particular kind of image, and I'll find the average noise, and that average noise will have the characteristic of that specific thing, that specific object. And if I'm taking any two noises together, as I have taken here, I'll add them up. There are two random noises added together, it will generate a new random noise. Right now I have taken the noise of Indie and Persian cat. If I combine them together, it should have the feature of both Indie and Persian. I'll give that noise to a generator, and the generator will generate an image that has the feature of both of them. That's beautiful, right? In the exact same way, I can change the noises. It will generate variation of different things and so on. So in the exact same way, image generator works. GANs are not very great at generating very high quality images, but they can generate images. Can be easily faked, but for that purpose, we have autoregressor and diffusion based model that will generate very realistic images. In GANs as well, we have different kind of architecture. This is a very basic architecture. We have cycle GAN, we have vanilla GAN, we have NVIDIA has launched their GAN in probably 2016, 15, 16 of generating realistic faces. That is at that particular time was a big thing, because before that there was no one who can identify this is a real image, this is a fake. So this is how the noises are working. So apart from taking Indian cat, I can also divide it into two separate noises, Indian cat, Persian cat. So both of them are cats, so there will be a single noise of cat. So for everything we can have a noise. For every word you should have a noise. If I can have every noise for every word, so the noise is basically the summary of that object, of that person, or that whatever. If I take all of them, and if I'm giving a sentence like this, black Indian cat sitting on grass early morning in Antarctica. So every word has their own noise. And because every word has their own noise, so I can average the noise together. But not like this, because every noise has their own weights as well. Because if I'm talking about on is not a very important feature, but grass, cat are important. So accordingly, I'll also average out the value. So it's like a weighted sum, not direct average, weighted average. So this one will have the context of the whole thing, and given this to the algorithm, it will generate an image. And we can take another example, and for that example as well, it will generate an image. And this is how generator adversarial network works. Okay, this is very basic details that we have thought, but this is under the hood how it works. And that's it on the lecture of GenAI like never before, where we have discussed about generative adversarial networks. Okay, I'll also give a link in the description where you can check out the whole notebook, how you can run your own generative adversarial network from scratch. And apart from that, there will be a dedicated video on the tech part of that as well, where we are going to write the whole code of generative adversarial networks. And that's it for this lecture. I'll see you in the next one. Thank you.